In the last video we found the spacing s equal to 90 millimeters. Now we like to distribute that we need to find out how much spacings we how many fitments we can provide for that spacings. Now recapturing the few highlights that we done so far. First steps, we find out this 326 millimeter of spacing based on this VU minimum. We find out the minimum capacity, and we find out 326. Second, then we go ahead and work out this spacing, which is 165 millimeter in this region. Now we are working in this region from B to E, where we have found just S spacing is 90 millimeters, and it logically makes sense that we have 165 millimeters, which is 343 kilonewton resistance. We need to resist 437, so definitely we need more closed fitment. So 90 millimeters makes sense. So check your answers just closely here whether it is logically making sense or not. Now we need to calculate how many spacings we can provide. So this distance can be used 1640 millimeters. So that distance is 1640 millimeters, measuring from the center of this, and this is, let's say, support B. Okay, I just redraw the portion of this from the support B. Now in here we have a distance which is, we calculated 1640 millimeters, and Australian standard is saying that we need to extend this as equal to 90 millimeter fitments to the up to distance capital D. Now that is given in the standard. Now if you check the clause 8.3.2.3 on page number 125, it is clearly mentioned that we need to provide this distance D, which is in the decreasing direction of decreasing shears. So based on that clause, we can add 650, and D is given in the questions that we have a D value which is 650, which has a D 650 millimeters given, that we plus here, that is given 2290, and 1640 is coming from here 1640 millimeters, that is give us 2290. Now please note, this is measuring from the center of the supports, and the first fitment should be provided 50 millimeters from the surface of the support. That again written on the same clause 8.3.2.3 on page number 125. It says that first fitment should be positioned not more than 50 millimeters. So we take 50 millimeters to position the first fitments 50 millimeters, and that makes sense because we have 50 millimeters here, and that is makes sense that this is the starting point of these fitments. So we can't put these fitments far away from 50 millimeters. So that is 50 millimeters is a starting point, and now we need to find how many number of fitments we're going to fit in this region 2290. So to calculate this distance, which is 2290, that's take away 50. This is the position of the first fitment. Take away 150 because this support has a width 300, so we take away 150. So this 2290 take away this one is give us this 2090. So this distance from here to here is 2090. Now we need to know how many fitments we can place in here in the equal spaces. Now we know that spacing is 90 millimeters, so 2090 divided by 90, it gives us 23.2. that is give us so we can't put 23.2, so we just approximate 23 fitments. So we can put 23 fitments at the space of 90 millimeters. So now summary here, we have these 326 millimeters, 165 millimeters, and 90 millimeters, and as I mentioned somewhere, I written that spacing will be rationalized later. If you remember that in the previous video, I mentioned that rationalize means that we are squeezing this zone by distance DD, because this spacing 165 millimeter will be extended at distance D in this zone, and this 90 millimeter spacing will be extended at a distance D. So this zone will be squeezed, and this will be rationalized at the end. Now last things that we like to do it, there is a remaining spacing left. So what we done, first we calculated here 326 millimeter, 165 millimeter spacing, and 90 millimeter spacing. Now we like to calculate how much spacing that we are providing at support B towards the C. So that is written here, at the support B on the C side. So on the support B on the C side. So let's say support B on the C side. Now the same strategy we're going to follow. Again, the cracking cannot extend into the support, so the cracking will not start here. Cracking generally start a little bit distance from the far, but we need to know what distance we going to start. So in that case, the standard is giving us that indicators that we can use the distance d0 from the supports, that is written here, that maximum transverse shear near a supports in the 8.2.3.a on B on page number 115. It has distance d0 from the face of the support, So we put the distance d0 from the supports. Now if we can work it out here. We have equations, straight line equation. V star is this slope is minus 150 going down, so minus 150x, and intercept is 270. Now this x distance is the one that is measuring here. This is the x distance, which is nothing but 0.150 meters, and this d0 distance. Now d0 we calculated in the previous step, so not recalculating here again. That d0 we calculated here, which is 586 millimeters, and that is 0.586 plus half is 0.15 plus 220, so that is given 160 kilonewtons. Now very easy to see that, okay, if you have indicators that we calculated this VU mean, 5 VU minimum, that is 191 kilonewton. Now please note, this 160 kilonewtons is less than 191 kilonewtons, that's 5 VU. So we can provide the minimum fitments in this region. Minimum fitments meaning that if you remember this, in this zone, so this VU minimum in this zone, if you remember that VU minimum in this zone we calculated 326, so same 326 can be applied here, because this design 160 is less than 191. If it is more than 191, then we can follow exactly the same procedure that we follow here. Thank you very much. Fitment layout will be explained in the next video.